Okay, so hello everyone. Thank you very much for coming. It's good to see so many of you here at an in-person event finally. And so I'll just give it to our speakers. Steve and Dennis will be starting the talk now. So thank you very much for coming. And yeah.
It's a real pleasure to speak about collaboration. Today is the topic architects and engineers, or engineers and architects collaborating together. Steve and I'm an architect, I'll introduce myself in a minute. We had collaborated for a period of 5 years, 20-ish years ago. So today is...
It's not as long ago as it seems. I mean, like in 20 years' time, this will seem like...
This will seem like the shortest tip. What we'd like to talk about today is the nature of collaboration today. I'm really interested in how collaboration has to sort of come to the forefront of working together. It is the mainstream. It is for your generation. You will know nothing but collaboration. Part of what we're going to discuss today, sort of what my little bit is going to be what collaboration is not. So for me, if we're good for that. Oops, so this is my introduction. So I'm a trained architect. I'm from the US. I was educated in New York, practiced in New York for 10 years before moving to Paris, practiced in Paris for 4 years before moving to the UK, where I have been living and working for 24 years. I had been working with very large practices for up until the last 6 years, where I established my own practice with my partner, daab Design. We are a small fantasy-based practice, and we do works on small and large scale, micro to the macro. My experience from 1984 to 2015 were with very large practices working on large infrastructure projects where collaboration was introduced to the profession at the time. So that's my share.
That's me. I'm Steve McKechnie. I'm an engineer. I did a degree at Exeter University and started work with Arup partners, as we called ourselves in those days, in 1985. I worked in the Bristol office of Arup for 13 years. These are some of my favourite projects from over the years. This is an enclosure to keep the penguins safe at Bristol Zoo, which they're about to knock down because they're moving the zoo out of town, which is a bit of a nuisance. This is my most current project. I suppose that's a 90 long acre in Covent Garden. We are cutting and carving an existing building, increasing its area and repositioning it for the 21st century. Building reuse kind of ways. That's what's going on at the moment. Number 8, Bishopsgate, we'll talk about a bit more later on.
For me to discuss what collaboration is, it's almost important to discuss what collaboration is not. A lot of buzzwords going around now. Collaboration is not just good coordination. Collaboration is not the traditional design team where there's an architect, an engineer, engineering services engineer, structures engineer, sustainability, and series of consultants. That's a traditional design team. That's how projects have been structured for very long periods of time. Collaboration is not just, oh, we get along really well with our engineers. This is from the architect or the engineers say, yeah, those architects really aren't, you know, such jerks after all. It's about working together. It's about a fluid way of communicating and what they call workflow. So to continue with what collaboration is not, although this is a photograph from GM drafting room in the 60s, it wasn't too long ago where architects and engineers were very much working like this. And I don't mean the drawing boards and the low tech and everyone's white and there's not a single person of color on it. It used to be, it wasn't too long ago. Everyone had a task, and you sort of participated. You plugged in your task. You were never driven by the overall picture. You were never driven by what am I actually contributing. You were incredibly faithful to what you were delivering. You were faithful to the hierarchy of the project, of the office, of the structure. And what happened, especially in the UK, so this is great because I'm not from the UK. I'm going to tell you about the UK history. What happened in the UK after the Second World War was a rethinking of industry. And some of it was just by sheer necessity. It was how to take a wartime industry and readapt it to post-war. It was also part of looking at how do we source raw materials, how do we upgrade our infrastructure, our manufacturing infrastructure. It also looked at how do we begin to understand the needs of the customer. Customer back then was never discussed. It was incredibly hierarchical. There were big clients, usually sort of related to some government or some sort of aristocracy, who were ordering things. And people were fulfilling those orders. And how you fulfill those orders were never discussed, no question. What happened in the 50s, 60s, as students, you guys should really look at these. Basically, every 5 years, the UK was introspectively looking at the construction industry and questioning itself, usually for good. A lot of times, because when you start to get into the 70s, when you join the EU, it was looking at where the Spanish, where the French, where the Italians doing. Also, they became competitors for large-scale projects. So what happened, if you fast forward, between the end of the war and looking at raw materials and how do we make and move and tune our equipment, it very quickly turned into people. It became people-oriented. And oddly enough, the construction industry has been, the UK construction industry, has been a leader for this whole approach of integrated design teams, IDTs, concurrent engineering. How do you work together with multiple consultants? So what it did, it took the traditional 1960s version where architects would meet with a client, have a brief, draw things, pass it to the engineers would look at it and say, we need to take a little bit more time. And then we pass it back to the architect say, oh, you really ruined it, let's do something else. And this whole sort of linear movement of information completely ceased with, between 1995 and 1998, the Latham and the Egan reports were critical. 1998 is when I joined Terminal 5. Steve joined a year or two later. Terminal 5, which we'll get to in a bit later, is the antithesis of this sort of Egan ethos. It's what has driven UK industry since. Crossrail, Jubilee Line Extension, Olympics, Vauxhall 9 Elms, Battersea Power Station. Every project, there's not a single project in the UK that has not been affected by this way of working, which is about collaboration. So why do they collaborate?
Why do I collaborate? I first want to talk for a moment about why I do this job at all, and that's because I really like making things. It is the feeling that you get when you see something that you have imagined with your collaborators and thought about and designed and analysed, and somebody builds that and it becomes real in real life. That is kind of the best feeling, almost the best feeling. And that is very much why I work in engineering design. It's not for the money or for the fame. And in order to do that, you have to collaborate. At the very sort of basic level, like Dennis said, you have to collaborate because it is not possible for one person or even one artificial intelligence system to have all the knowledge and skill that's required to design all the multiple different facets of a building, its technical aspects, its human aspects, the beauty, the feeling of what a space is and what it can be. So you require a large number of people to do the job, but that is not enough on its own. Collaboration, as we talked about, requires much more than that. but it requires that the people involved can listen to each other and include each other. All the people with the right skills are working towards common goals, and they may well need patience with each other in order to understand and learn, and they need curiosity, and a growth mindset is a thing that I learned about from schools quite recently, but I think that's a really important concept. Perhaps it's summed up by these things that I put in red: people with the right skills working with a problem-solving approach, which you might also think of as building growth mindset. It's finding ways to fix things and not being fixed in the way you approach it or who particularly does the fixing, but it's finding ways together, working towards a positive, successful project outcome in all the many facets that involves, and also a desire to get things done and to move forwards. And I call that passion. That's a word that we use a lot these days, isn't it? So when that happens, you have the opportunity to not only integrate the structure with the architecture and the mechanical and electrical engineering, you have the opportunity to come up with a building that is more than the sum of its parts because of the way they complement each other. And when I was trying to think of a building that epitomized that, I thought of a building in Beaubourg where the structure is a key part of the architecture, and the architecture is a key part of the structure, and the MEP systems and the vertical circulation are a key part of all of that. And it's a special solution that has come together from minds working together and thinking about every detail as well, from the most overall view of the building down to what the texture of the steel is when you walk up to it and touch it. It's a very special thing.
So this photograph, this is the Centre Pompidou in Paris, 1973 to 1977, is the epitome of collaboration. This is almost 20 years before the Egan report. What it is, it's mutual respect. It's services engineers sitting around, and back then, and even today on many projects, services engineer, perhaps for the first time, hearing an architect saying, can you explain why the ducts need to be here? If they're coming from this mechanical room and they're branching out, can we organize them in a certain way? And services engineer would say, why don't you have a ceiling? No, we don't have a ceiling, we'd like to see that. Why do you want to see it? Because we think there's something. And what happens is, it becomes this sort of, this thread that you pull. You're showing a level of curiosity for the non-service engineer, so for the architect. And the service engineer is saying, Craig, it's the first time someone's really interested in what I do. This building epitomizes that, and that's what is the beginning of collaboration.
Yes, and I've sort of put my tongue slightly when I said that what you can create at the end of it is a part of the legacy of humankind. And I think Terminal 5 that we worked on does come to that. I also think that the house I live in at the moment, where I'm repairing it, that counts as part of the legacy of humankind as well, because it's been there for next years, and I'm going to pass it on to the next people. But I count my work, our work, as something that is for the future.
This image is a design session early on in the Terminal 5 roof design. The photograph previous is taken probably 9 years after this meeting. In this meeting, we've got engineers, structural engineers, services engineers. We've got Derby Mitchell, John Thornton, and we've got Richard Rogers and partners at Paris.
That was my boss. That was Dennis's boss.
Yeah. And what's happening at this meeting is a discussion where the engineer is putting the architect to task. If this is what we really want to do, we're going to have to do the following. And then the architect said, well, if we have to do the following, can't we understand how this might be expressed? That's an interesting idea. If we express that, then the load path is changed. However, what you've suggested is an improvement to the load path, by the way. And it is a fluid, open discussion. And what it then does is it begins to set a mindset. So a bit of Terminal 5 context. There were no contract, there were no tenders. The structural engineers and the architects, the baggage handling company, the steel suppliers, the concrete suppliers did not respond to a tender to win the project. The architects won the competition, and then with this Egan ethos, Heathrow said, we're going to create this framework, 16 top-tier framework suppliers. And you signed a half-page agreement that said, you will open your books, you will show rates that you pay your employees, and you have a right to add a 10, 15, whatever percent on top of that. If you're a supplier of material, you will show us the entire procurement route, you will show us the cost of every nut, bolt, and then you have a right to have a profit no greater than the following. And you will do that at the best price, best advantageous price to us. And it also said, we're all going to figure out together how long it takes, how much it costs, how we build it, and there's not going to be a single person in that 16 who will not be linked to the responsibility of success. And that was a real key moment. So what's missing in this cross-section are the 5 levels of building, which generate from grade upwards, and the 2 levels of basement. See here, 2 levels of basement that happen from grade below. Steve and I and a group of 6 other architects, 4 to 5 other structural engineers worked out for 3 years-ish more how we're going to build it, how we're going to erect it, how we're going to fabricate it. And then the circle got bigger and bigger. And the steel contractors they were part of the first-year framework, so they were around the table. Framework, the steel suppliers, when we started to get to these major nodes, what we call the foot, torso, hand, and wing. As architects, we were pushing in a direction. As engineers, there was really interesting, let's do this, but we can't do that. Also, the structural steel castings became quite important as the key component. So that circle got larger and larger. The framework structural contractor was obliged to go out and bring in, at his level, a casting foundry. And then you can't just cast, you got to machine stuff. You can't just machine, you got to transport. What happened is, Steve and I were part of that selection process. We were brought in, and we interviewed the structural steel.
And it was great fun because we went around to visit all these factories.
Up north.
Which is brilliant. Exploring there, all of it. Huge machines.
Absolutely mind-blowing foundries up in River Dom, forge masters, who were doing these 16-node steel castings for the offshore oil industry. What we're saying is, we then had a voice of voting whether we thought this company was the right team or not. And it sounds incredibly naive, but we did. And I had this I really liked this company because they were doing everything in 3D, but they were building hand models to kind of see if you could actually lift the bit out of the sand after this casting. So what happened with this design was no one used the word collaboration back then. And then, if people did, we probably would have been skeptical and thinking it's just a managerial bit. But what it led to, in what we see and feel and touch when we walk through the building today, is, I think, what I feel, a product that just benefited from everyone's involvement. And these images, the top row, are the development of what we call the foot, which was comprised of 1, 2, 3, 4 structural steel castings, a whole bunch of machine elements. And it was all about how it was going to look, how it was going to function structurally, how it would withstand movement, building tolerances, direction. And what then happened is this image here and there's an image that we'll see a little bit later, is in the office out at Heathrow, where there were 325 people working anywhere from 1998 to 2002, and then we broke and went into all the port cabins on site. What happened, we were building models of everything, and the structural engineers were really getting into the model. We wanted the model to understand what it felt like, the geometry, how space would be perceived. The building managers said these models are a fire hazard, take them down, get rid of them. And some of the upper tier management at Heathrow was saying, you guys are playing with plasticity. Is that what we're paying you for? Just to get this crap out. Until steel supplier and his crane operators. So actually, we need these models. And the crane operators would come here and would look at that and would look at how are we going to pick up that piece? What's the clearance going to be? How do we rotate those on? It became the most important tool. And we didn't just cross the threshold of collaboration. It became so embedded at the bottom of the pile, the crane operators were forcing the leverage to Heathrow to say, these tools are essential for what we're doing. Bottom images are the early manufacturing. So it's a series of F-scale models up until the pattern, the positive for the casting. Those pieces are full scale. They then get placed upside down, put into a pit. They spray sand with an epoxy adhesive all around it. They pull out that orange bit. You have a negative. You put on these precast sand tops to it with all these vents, and they pour in molten steel. It was the most amazing process. And again, the geometry of all that was influenced by the casting foundry people looking at early models that we were doing and early geometries and saying, we can't cast that, or there's going to be a great big line around here where we're going to have to break the mold. And I can tell you that line will be there forever. So, oh, don't you just grind it out? No, you don't grind it out because you're going to have a difference between the cast surface and the ground surface. It was a truly collaborative environment where every aspect of what it was we were doing became relevant. Very quickly on this photograph, this is up in Thirsk, right up, where there was a practice. The crane operators and the steel were practicing how they moved lifted pieces, and was it erectable? Came down the site, and that whole erection method of lifting the roof first and building a building inside a building, which could be a whole nother lecture, was all about a collaborative buy-in to a single idea, scale, and inclusion. So we've got some of the crane operators on the lower right, sense of scale and the image on the upper right, and the environment in which we worked. And Steve's desk was right here. And these are engineers from Arup. I was here with our team, and we had a completely integrated design team. Didn't matter what company you were from, didn't matter who your boss was, it was all about working on the same spirit of project. And the use of models and scale and practicing. There's a great image of Steve and I in 2003 up at the practice.
Fun study.
Yeah. Fantastic image. I always wondered what would happen if that chain broke.
So do we want to do we've done 20 minutes or something? Should we dash on the next?
Let's go on to more, and then we can come back should you need to.
Those were going to be some slides about some more details of Thermal Fund and how the details included the needs of all the different parties in a collaborative way. But this is another collaboration story, which is a bit more recent. Number 8, Bishopsgate. You can see it there outlined in red. When we joined the project, we got hired by staff effectively. The architects, Wilkinson Eyre, had done a competition entry, and this came from their, all these images came from their competition entry to the client as their design references. I wonder if you do that today. I don't know. That was 2013.
You still do that, yeah.
And that's a watercolor by Chris Wilkinson, who just died at Christmas. And this next page is one of his sketches. He sketched that on my iPad when we were talking about the bracing and the building. Right.
Pretty clear.
So it became clear quite quickly that in order to make space for the city that was lettable and had a good value to the client, right? They could let it for a lot of money. It needed to be in rectilinear shapes because that's what the market wanted to rent. So we had to change our minds from that swoopy shape to a rectangular kind of geometry, rectilinear kind of geometries. There is also a key constraint on that site, which is the view of St Paul's down Fleet Street. In the distance there, you see the outline of 122 Benhall Street, which was already built by then. We couldn't extend beyond there. So this geometry here of stacked rectilinear boxes responds to that geometry behind it by tucking itself into the same piece of sky, right? We also knew, I should have some.
Yeah,
Right.
You had a wind movement animation?
Oh, that's right. Yeah. No, well, look, we wanted to use bracing on the perimeter because that gives you the opportunity to make it. It is much stiffer and stronger than putting your stability system in the central core of a building. With this building, we were able to reduce the thickness of the core walls from 550 thick without this perimeter bracing down to 300 thick, which is a big saving in concrete volume and in embodied carbon. So we really wanted to do that. We wanted to use this bracing system in the perimeter, and we were talking about that with Chris and with the other architects at Wilkinson Eyre, Oliver Tyler, who might have met him, which is occasionally here, and Eamon Toner. So we wanted to use that system, but the client and the architects didn't want something that looked like it had a truss on the outside of the building. So we tried to do a bit of optimization. We generated random, because the number of possible arrangements of braces in the building is so enormously large, into a really huge number. You don't need braces in every bay in this building. You only need a few. But which few do you need? Because the number of those braces was so big, we decided to choose them, generate them at random, and to test them for how good they were in terms of the building stiffness and the forces in the braces and whether it was going to overload the rest of the structure. So we tested 21,000 options and chose the most favourable one. Having done that, we had a braced section at the bottom of the building, and then that slender core carries on up and has a nice slender open section at the top, which has very clear views out. But the client wanted more area. The more area you can put on the site, the more rent you can charge, the more successful the building is commercially. So we needed to find more area. We knew that the client owned the space, the pavement, and also part of the road, even though it's public highway. It was owned by the client. So we suggested that this braced section of the building could cantilever out over the road without really adding any extra steam. So we increased the floor area, 75 million in rental income increase from that increase in floor. Also later on, and this was this was a sort of quirk of the planning process. We discovered, this is in 2018, the planning had gone in 20, something like a year or two before, and had been given planning permission, but the thing had been quiet. There was a building on the other side of the road that got planning permission and was slightly higher. But the planners had made us put this observatory at the top of the building. There was a viewing deck. And the building on the other side of the road was right in front of it. So, so Wilkinson Air pointed out to the client and then to the planners that, look, we wanted this observatory, so you're going to have to allow us to go a bit higher. So we had to put an extra 13 stories on the building, which again, that increased the rental value by 120 million, and the project started going at that point. And so that brought value to the client, and it brought value to us.
Did the additional 13 floors have any significant consequence to frame below?
Yes, yeah, you know, it increases all the sides and so on, but the cost per metre squared of the building overall actually reduced because there's a bit of 2016, yeah, 2016, we must have got the permission. 2018. So overall, we were quite proud of our performance in terms of steel quantity in the building, which is what we were thinking of a few years ago. We managed to beat most of this graph of steel quantities in buildings. It looks a little bit lackluster when you compare it against the score rating. The scores rating that we would be trying for now, we'd be aiming to be up here now, but for the time that was good. And I put that on the slide there because we are now calculating an embodied carbon value for every building we do, even if we feel slightly embarrassed about it, because that's a learning thing. And the next time we're going to beat it, it's going to go down, down, and down. And everybody's talking about that. So and this was a special group because it achieved planning and because it attracts tenants and it was buildable, and it's achieved a really good energy in use a rating, 40% better than building regs. The embodied carbon is good for its time, and we as a collaborative design team working together were able to gain the area, enhance that rental value, and make the project go ahead.
Geneva Airport East Wing is a project I ran for Register Carbon Partners from 2010, where we had the competition in Switzerland, Geneva, Switzerland, and until 2015, it just opened just before Christmas, 14th of December. I use this as an example of collaboration in a cultural context. That slide I had up earlier between the 1944 to 1998 and the introspective analysis of the construction industry in the UK to better itself. What's interesting is when you work outside of the UK and you begin to understand that there are sounds completely idiotic, but there are obvious cultural differences, and there should be obvious cultural differences because this is not a amalgamation of cultures. This is each culture should work on its own. Very, very quickly, the Geneva East Pier is a very it's 520 meter long, 2-story passenger facility for the Geneva Airport. It's essentially, except for immigration outbound and inbound, there's no baggage handling processing. It's a very light, process light building. It has incredible complexities of the site where there are an adjacent performance hall, exhibition hall where they hold the watch show, the annual automobile show, and the annual chocolate show. Those three shows bring an enormous amount of revenue and are important cultural events if you're Swiss. What was really interesting, so the scheme that we put together that won the competition that was eventually built leaned. It leaned away from an adjacent campus where graphically the exhibition hall, which ran for about 300 meters, was right here, and it leaned towards the aircraft, improving glare or removing glare from the facade for the pilots who are negotiating the airport, taking off, landing, taxiing. Structurally, really interesting building. The entire exoskeleton is exposed. There's a major diagonal. So there's diagonals crisscrossing down every 80 meters along the 520 meter length. It's big, long extrusion, where you get different conditions where there's either an arrivals corridor or an arrivals corridor and processing, or at some point there's an entire floor. This is at the annex where it makes the appendage to the existing building, so there's a whole immigration process. The cultural differences, what I talk about is Geneva is part of the Swiss Romand. It is the French-speaking portion of Switzerland. Obviously, our consortium were made up of a huge multidisciplinary Parisian-based engineering firm called Arup, RSHP, a local architect, and Arup had employed local structural engineers, services engineers. What was really interesting with this project is you step into a minefield of French-speaking Swiss getting irritated by French-speaking French, and I'm a French-speaking American, sort of having to be the translator for the group. But more importantly, because I had worked in France, I knew that whereas almost all of my colleagues at RSHP did not understand, nor did they have an appetite for, nor could they tolerate the fact that French engineers traditionally don't have a culture of collaboration. There's very much a French architects are the cliche of the artist doing the sketch, walking away, and then receiving the drawings from the engineers, freaking out, telling them it's a bunch of shit and you are useless, go back and do it. The engineers go back in their office, say what complete wankers these guys are. And they come back, they fix it a little bit. Everything is about fighting, and it's trying to get a sort of compromise somewhere. This building, with a bit of perspective for me, there was a lot of fighting. There was a lot of cultural fighting. There was a lot of Anglo-Saxon, we know. There was a lot of colonial almost. We should be collaborating. And what colleagues were saying was to the engineers, we should be collaborating, meaning, can't you just make it stand up and shut your mouth? And I used to be like, oh, we can't do that. If we're true about this collaboration, we're true about wanting to build elsewhere around the world. You don't do what we used to do up until 1957. We don't impose. The end result of this project and the people who built it and the relationships of collaboration, there are some incredibly strong relationships. Steve and I have a great relationship. But one aspect of collaboration is this idea of, as architects and engineers, we put 4, 5, 6, 8 years of our lives on a project. Then we go on to another project, and there's a whole other group of people. And if you have a culture of collaboration, those other people sense that, and you feel it. And you kind of walk into that next environment with an understanding of, we're going to get through this. You're not going to be the classic jerk. You're not going to be the classic curtain cold engineer. We're going to find something in the middle. The end product of this was, I think, a pretty successful building. But I almost faulted for that process of not listening and not willfully accepting engagement. How are we doing for time? What this segues into is that collaboration is about communication. It's about graphic communication. It's about ditching the process before architects draw 4 weeks, 2 months, send dossiers to the engineer, they take 2 months, and then send the dossier back, and then it's about working together in the same room. Steve and I would do sketches and roll my desk chair over and say, Steve, what do you think about that? It's going to be not going to be wide enough. How much wide, Steve? A little bit. And I'd go back, what do you think about this? Well, that can work really well. What if we do the following? So this whole idea of you circumvent this sort of pass the parcel approach. But most importantly, I think I became a better architect by working with an engineer who became a better engineer, because we were for the first time seeing live and real time, which we didn't use back then. But this idea of how people react to an idea. So it's about communication. It's about everyone's buying. And that's what's really interesting. Your generation, let's slide that Steve had with all the words. On big projects, that used to be sort of the manager would come in and do these presentations. And there'd be that dreaded day of post-its. Post-its on the wall, where everyone writing what's your dream. But now it's embedded in every project, not the post-its hopefully, but the idea of this communal buying, and it's not bullshit. It is how projects are going. It's getting up until the procurement right now. Procurement has changed drastically. These big projects are all about looking at the design team and understanding all the sizes, scales, colors, cultural makeups of the teams. This is no longer about one big conglomerate saying, here we go, we're going to provide a team. This is a picture where there are far too many white men. And it was a period where it was the beginning of this idea of everyone's say, everyone's word makes sense here. Around that table are engineers, architects. There's the gentleman pointing to the model is yet another structural engineer who was just responsible for all the temporary steelwork. And he was essentially, he's presenting to the project leader from Heathrow. This is how we're going to do it. And I'm here as the temporary structures engineer to explain to you, as opposed to the architects or the engineers who are quote designing the building. And it just gave this whole air that everyone had a stake in. And that's what the future is. So for your generation, it is about getting, everyone's voice. It's about the understanding, the acceptance that the built environment is no longer going to be shaped by a whole bunch of white guys. It's going to be shaped by everyone who have the ability to work together, collaborate, share ideas, and articulate. And I think, hopefully, that can spur some questions. So I don't know if we want to go any further, or how are we with time?
No, I think that's about our time, isn't it?
Yeah, would be good. Do you have any questions?
It's a bad sign if there are no questions. So, we're already on.
Yeah, I had a question about the individual state. Like you use the randomly distributed pricing,
Yes.
and after that, did you do anything about this? Or you like 21,000 iterations? You choose the best one, and you left the best one.
Well, it didn't end up quite that simple, because there were good reasons to move some of them.
Yeah, exactly.
And actually we tweaked a couple of others because we found ways that we could make the flow and structure more gentle. So if we'd done 42,000 or 21 million or something, maybe we would have shown the final one we ended up with. Yeah, so we did change it a little bit for because of the way it looked, and of the way the building looked, and also because of the way the structure looked.
Yeah, and what parts of this distribution of this mountain do you translate other parts of the structure as well, like for example, in cross sections, size of the cross section?
At that stage, we just wanted to pick the arrangement.
Right.
So we fixed everything else, and we just did different arrangements in order to find the best arrangement or a good arrangement. After that, we sized the things.
Did you do this the second time after you added those 30 stories and after you changed the?
No, it was we had the arrangement and stretched the top end a bit.
Do you think that you could change anything to actually do it second time? Because you changed the geometry of the building, so the structural system worked accurately.
It would be interesting to try, wouldn't it? We were limited by computing power, really, and the amount of time it was taking the iteration to go through the things. It'd be interesting to find out. It's funny. It was a lovely idea, and we were excited by it. And everybody in the design team said, "Oh, yeah, that sounds really interesting." And I started explaining it, and most of it sort of stuff. So it's sort of a good idea, but it's.
But with the 21, were some of the parameters, wall thickness changes,
The parameters were the amount of force in the biggest compression force in the brace, the biggest tension, or the smallest tension force in the brace, because it's a nuisance, which would translate into the compression force would translate into more thickness. The smaller compression force is smaller, more thickness. Tension forces kind of translate into awkward connections. Compression connections are better to the tension. There was like the overall thickness of the building, the maximum compression in the column mode. I don't know, we could go back to the slide and see if we can read the things across the top. I thought of about 9 different things we could measure and add up the composite score and weight of them. Yeah, it's good fun.
It was 2013, right?
Yeah.
Was that big popular practice?
No, we made that up.
People more and more like this generative, like adaptive structural systems, but 2013 was that popular to random like distribution with a lot of times check which one's best. Certainly.
It was I read up on optimization techniques at the time, and we had done some optimization of special structures around then. We had a fashion for a previous project that I worked on, which is now, it was a building that was planned to be on the site of 22 Bishopsgate, so just next door to number 8. And there was a team from Cambridge who worked on optimization of the structure. So I looked at it and studied it a bit, and there were a few examples in the industry, but it was fairly unusual.
Thank you. Another question?
For me? So first of all, I would like to apologize for coming late in the meeting because I was having an experiment in lab. I now have a question. First of all, I have applied for environmental design engineering MSc program in Bartlett, UCL. So could you please tell us whether you have any experiences in collaborating with built environment design, like using the software design, the sunlight and the lighting and the acoustics and human thermal comforts in the building, just like the building service sector. Could you please tell me your experiences collaborating with them?
There are many consultants who have environmental degrees from Bartlett. It's a very good degree. It is a very potent consultant profession. So, and Bartlett is a very good school. And they do, what's interesting with some of the small consulting firms, is you're getting collaboration from day one. You're getting a buy-in, you're getting input on facade approach, facade design. So it's an incredibly useful interface.
Oh, excuse me, how does facade design relate with the built environment? Is it like the shading in the glazing?
It's the idea that we can't continue to rely on these big glass boxes and throw a little bit of low E coating and then maybe put some shades on the inside. We can't do it anymore. It's just it's not permissible legally, ethically. We can't. We have to rethink that. So what happens is you start thinking, well, how do we get vision out of the building? How do I take benefit of natural light so I can turn the lights off? And you need highly tuned in consultants for that. Solar shading on the outside, used to do the trick. Solar shading, the Geneva project was classic. We were leaning. Geneva, the Swiss are incredibly compliant on building services and energy use. The building has 108, 300 meter deep geothermal piles. It has 4,200 photovoltaics up on the roof. It's completely independent from any grid or carbon 0, 0, 0. And it was all through that type of consultancy.
So
Just one thing, Nathan. I'm sorry for interrupting you, but we really don't have time, so it'd be great if we just have another question. Really sorry for interrupting you. Yeah. So if anyone else wants to ask a question.
Yeah, hi. So I'm studying engineering and architectural design, and we've been hearing a lot about the position of the lead designer. And I was thinking, since we're having this talk about collaboration, it's all about bringing the engineers and the architects together. Do you think that the position of the lead designer would be a way to mediate to that conflict between both parties, or would it just put the blame on someone to try to reconcile between everyone?
There's lead designer, and then there's principal designer. Principal designer is the person who's taking all the liability and leading all the health and safety. That's an industry all in of itself. But the lead designer is key. It is it's an adaptation of the industry. Some architects, there are lead designers who aren't architects, who are big A&E practices, who hoover up these big projects. There's a bit of protectionism from the architects. There's a bit of huge push from insurance, PI, and development that is saying, we want someone who's not going to be perceived as being the irrational architect. We want someone who's not going to be the cold. We want someone who's going to lead us. The word lead is on the tin, but it's not incredibly clear the direction it's going to go. We respond to a lot of tenders to be lead design for small affordable housing, and we're very, very comfortable with that. What it will tend to do on large projects is, unfortunately, say it goes back to that same top tier of practices who are architectural practices, 150 and personnel and above, who will be controlling the built environment. And that's, in my opinion, not right.
But for any project, designer is a very important person. Yeah, like a conductor, aren't they? Or a chef, I suppose, in that they perhaps are not playing the instruments themselves, but they're and it takes a particular sort of person to do that job well. And it would be to do with their personality and the way they relate to people, and it would be to do with the way they imagine the project and understand and listen to what people say and hear it. Something new and to inspire the people who work with them. So they are the big ones are very special people.
And the whole tone of what level of collaboration will be established from that group.
Yeah,
it's yeah. It happens on every project. You had a question?
Yeah, a very quick one that kind of stems from that actually. like we talk about collaboration and it's always so beneficial to any project, but we never, I mean, at least in my studies, because I also do the engineering and architectural design program, and we never really talked about the difference in timing for these design projects. So has it changed? Has it actually, all this collaboration, to all the benefit that it has, actually increased the time of a design project and not also the financial constraints of that?
It's decreased the time.
Oh, okay.
That linear process is now radial, or it's circular. It's something geometric shape is not wrong. So you compress that whole process of an idea getting the whole buy-ins that you'll need. Does it stand out? Can we afford it? Does it meet the client's brief? And you get it relatively quickly.
And that you have to sort of see it in the whole project context. At Terminal 5, we finished the project on time and on budget. And that's really true of the group. I think it's almost true of the whole project, actually. And it was partly because we thought so much early in the planning about how it was going to go together, and we made the shape of the building and the shape of the pieces of the building so that they would fit together without causing trouble later on. That was a big focus, risk limitation. So the overall project worked really nicely.
How do you overcome those sort of difficulties that there are with collaboration in larger teams? So what you were saying about the Heathrow Terminal 5 project and the 16 different groups involved there, how did you go about working with all those different people?
I don't know what the short answer is, but you make sure that there is, it's not like there's no hierarchy. You know, it's not Animal Farm, and you work buy-in. So as the architects, our method of getting buy-in from, we had two plans back then, BAA, who own the land and charge landing fees to airline companies, and then we had the primary airline, BA, and they had conflicting briefs, if you will. So our buy-in was to work in the trenches with them and get it to a point. And inevitably, part of it was, well, we really want to create this flexible baggage hall. So what does that mean? We're going to really yank apart the service corps. We need buy-in from the service engineer early on. So you sort of do some things in stealth, some things completely out in the open. And of the 16, you don't just walk into a room and say, okay, what do you all 15 think? You build up, and you have to do some things in stealth. And then you kind of, they really like it a lot, and then you tell the other 12. I've been cynical.
Right. Yeah, and you have to choose the teams to work, with the right people in the right teams. We were very happy with that team. There weren't 16 directions. Project really, there was like 4 at the biggest.
In the room, there were 16 on the
16 on the whole. And the other 10, admin, but not the key members. So choosing the key members of the team.
Yeah, and there were moments where people would sort of meet with either one of the two clients and say, there's a bit of friction on this team. It's and it could be people on your team, and say, listen, I think we need to replace the following, but these guys I don't think are working quite well. There's personality. And it's making sure that you do speak, you do give everyone a sense that they're contributing something. And it's not lip service, it's genuine. And what happens is, also, especially in architectural practice, where you just by nature, some people are really, really keen on working out the concepts and troubleshooting. But some people who just don't want that pressure. They love the idea of give me a core to configure. Give me back of house, I'm going to work out. Or you get people who want to really help to understand the fire strategy. And what happens is in those big teams, you get these natural voids that you can then people fill in.
I want to ask if there was like sort of some key principles that you would pick for tomorrow's engineers and architects to create their own workflow when collaborating. What would those principles be? So like the end all be all.
Empathy, curiosity, try to be curious about what that other professional does. And curiosity isn't just a one way. You need to understand what they're contributing and really listen to what they're saying and saying, actually, I've got to change my principal thought here because it's just not working with what I really believe they feel needs to happen. And you know what? I'm convinced that that has to happen. Therefore, I have to change. And that's a hard thing to do sometimes. Empathy, curiosity, kindness. I mean, it just sounds like a cliche. It's not. That's big.
And you know what you're doing as well in the first place. There's a whole bunch of stuff that make a great design team. Many things to get there.
We time for one more question.
Well, if you want, yeah, but last question preferably.
Maybe.
So we said quite a lot about collaboration between engineering and architects. I suspect quite a lot of us, which is both of those. Do any roles currently exist where those two professions are merged, or do you see that becoming something in the future?
There are a lot of roles where you do merge the two. I would almost say that's client side. You know, being an advisor for the client is a key. In any industry, whether it's a multinational biscuit making company, you know, they need people who are going to know how and where. These are very important people. How, you know, where the need might be to build, to construct, and then what will that mean to that local building? And those people are the ones who really, when they're really strong, they listen to how buildings are built locally, and they don't impose. It's not, okay, we're doing concrete. Wherever, why we don't have a concrete culture? We don't have access. You know, oh no, we'll bring the concrete here. Why are we bringing the concrete here? So, client side, there's a lot of work. Even in large, in Arup, in large architectural practices, there are people who have joint degrees who are bridging. 15, 20 years ago at Rogers, there were several people who had engineering degrees and they were architects, and they came from the French system. And unfortunately, very few succeeded because there was very much, we're architects. I know you particularly know what needs to happen for the structure to stand up. But I need to hear it from this outside person. And it was a really weird thing. And there was some really good opportunities that didn't go anywhere because of that lack of buying of your own rhetoric to an extent.
Yeah, I think that for a person, it's really about finding the work that you enjoy doing and doing that work. And finding a place where you can do that, where you have, well, you need somebody to pay you money to do something that you enjoy doing. That's the key thing. And if you can find that, you do a good job. And what exactly it is that you enjoy doing, you'll have to find out by coming to understand your personality. The registration for the two
Are quite different.
Some people have both registrations. They are both very complex and multifaceted things, and one engineer can't do all the things that are engineering, one project, one architect, I can't do all the architecture on one project. Unless it's a very, very small project.
But it's a very potent combination. And tend to feel that people who are going to be taking that path might be more front end of the project.
Understanding the whole process.
Understanding the whole process and but never picking up an instrument, but saying, I think we need 15 brass and 35 horns, you know.
They might end up with the impresario.
Yeah, yeah.
Yeah. Okay, so thank you everyone for attending.